Good afternoon, everybody. Welcome to Scaling to Millions at DigitalOcean. Uh, my name is Ray Ramjwan. I'm a software engineer at DigitalOcean. So to get started, I'll just introduce DigitalOcean. DigitalOcean is what's known as an infrastructure as a service provider. And well, what does that mean? Well, if you need a computer or you need many computers, many hard drives, a lot of networking resources, that's obviously something you don't want to manage and roll on your own. So that's where an infrastructure provider comes in, and that's what DO provides. But what's different about DO compared to other cloud providers like AWS, GCE, or Microsoft Azure? Our goal is to keep our products simple and easy to use. That way, your job as an engineer, as a developer, is easier, and it's a more enjoyable experience. So today, I'll cover some products at DO that make your job easier, things that you can use to deploy your production applications. And we have quite a few, but today I'll focus on a few of my favorites. So before I get started, though, I don't want to just list products one by one. I'd rather present a story to you. And like something that you would normally do is start a project, start a company. So I think that's a good way to talk about DO's products by showing you how they would integrate in a company, in a project you want to build. So today's product that we build is Cat Giphy. Cat Giphy is great. It presents a lot of problems to us. We have to serve up a lot of content to our users in the form of cat GIFs. When we have a lot of users, we're going to have to manage automatically adding new resources, removing resources, things like that. So where do we start? Do we just run straight to DO and spin up some droplets? I don't think so. I think if most of you are just like me, I run straight to my laptop and I start coding up a cool project using my favorite tools. Maybe I use Go to run my application server, my favorite database, an in-memory cache to keep things fast. And you wind up with something that looks like this, right? Our application server talks directly to our SQL database. Like I said, we have our cache that keeps things in memory so we don't go to disk all the time. And we have our user content that is our cat GIFs, right? Users can upload their favorite cat GIFs, download some other cat GIFs that they don't have. Right? So our next step then is, where do we run our application? Right? Do we run it in our office, in our homes, in our basement? You could do that. You'd wind up managing that application server. You would need to be able to scale that infrastructure that you're building in your home, and it's really not tenable because when you need more disk space, you either have to wait for your disk order to come in or something like that. But I think we should use a cloud provider. And like I said, you can use GCE, AWS, Azure, but in my totally unbiased opinion, I think we should use DigitalOcean. So where do we start? Well, we start right here at our droplets page at DO. Pretty simple UI, not a ton of grids or products that you'll never use, but it gets you straight to the point, right? And our first step is right there. We go and we create a droplet. Very simple. After you click that button, you'll be presented with a screen that looks like this. Simple questions. How big do you want your droplet to be? Where do you want it to run? If you want to add block storage or monitoring or anything like that, that's about it. Within I believe about 54 seconds, you'll have a brand new droplet running. After you create your droplet, you usually get something that looks like this. These are just graphs that tell you about your disk I/O, your CPU utilization, and your bandwidth. For those who are familiar with virtualization technology, this information is available to us out of the box. The hypervisor provides this information to DO so that we know how to manage the virtual machines on the cloud. But we want a little bit more information, right? We want to be able to figure out when our cache is hot or full, if we're using too much memory. With that, we use DO monitoring. And our first step is to update the droplet with the agent. Now remember I told you we only have a limited subset of information available from the hypervisor. In order to get the additional information, we require to run an agent on the machine. So the first step is to install the agent on the droplet by curling this command. It'll automatically download the agent, install, and run it. And within a few seconds, you get graphs that start to look like this. You get more information, right? You get your disk usage, your memory usage, and you even get a list of the processes running on your droplet. Our next step is to create some alerting, right? If our disk is full or we're running out of memory, we'd like to be notified about that so that we can attend to the problem as quickly as possible so that it doesn't affect our customers. So in this policy, we want to set up our disk utilization. If it's above 80%, we'll get notified via Slack. That's just one of our integrations that we have with the product at the moment. More to come. Right? Great. So now our application is up and running, available to the public. Folks are uploading their cat GIFs. They're downloading cat GIFs. Everything seems great. So this graph represents the time our application's been up, along with our resource allocation. Here's today. We had our public release, and everything went pretty well. And users have been uploading content every day. We introduced a product, Random Cat of the Day, which just sends you an email with a funny cat GIF. There's some fun stuff behind that to understand what users will find the cat the funniest. But we have some upcoming products like recommended cats. We're forgetting about two things, though. At this point, our cache will be full. Well, what does that mean? World doesn't end, but our cache is full. Our users will experience a little bit more latent response times. So we'll have to go to disk more, right? But at this point, our hard drive is full. Now that's when we do have problems. Our application will fall over, and we won't be able to serve any requests either to upload cat GIFs or view cat GIFs. So how do we solve this problem? We only have so much time. Well, DO offers two ways to do that. The first way is through resizing your droplet. And you can resize your droplet up to a 640 gigabyte SSD with 64 gigs of memory. The droplet's unchanged, right? So there's no reinstallation you need to do, no new networking information you get. You get the same IP address, not a ton of work. The next step, though, is high memory. With high memory plans, you can get up to 224 gigs of memory and a 500 gigabyte hard drive. Major difference here, though, is that you have a brand new droplet. And the biggest impact there is that you have new networking information. You'll get a brand new IP address, right? So let's go with our high memory option. So we already know we're going to be configuring a new instance. And with that, we can take into account some other problems we've been having. One, which is application deployment. Right? We're going to need to spin up a new instance, spin up a new droplet, so you might as well take this time to address some concerns. Now, when we deploy our application, we write some new code, we deploy it, make sure it runs, it starts up, and in the really bad scenarios, we introduce the regression, we introduce a bug. And ideally, we'd like to not allow that to happen. It would be great if we could spin up a different instance, right? Spin up a different instance, deploy our code, run some actual integration tests, make sure everything checks out, all the code that we changed actually hasn't broken anything. And then when we verify that that works, move traffic over to that new instance. Now, that process is really simple with our floating IPs product. And it does exactly what we just talked about. It can automatically take traffic that's going from one instance to another. And we can do the same process we just talked about. Spin up the new instance, verify our code works, and then forward traffic to it. With this process, you don't have to worry about your DNS cache invalidating or a TTL to expire. You don't have to worry about your customers behaving correctly and that their DNS system is working correctly. You rely solely on the IP address, and DO routes the traffic for you to your new instance. So how do you do that? How do you assign a floating IP address? And like everything at DO, we try to keep it very simple. You head over to your floating IP screen, and you pick which droplet you want that IP address to be assigned to. Straightforward, simple, and you're done within a few seconds. Our next step is to take a backup or a snapshot, and in this case, we're going to use backups. But what that allows you to do is to take a snapshot of your currently running instance. You can take a live snapshot so that you don't have to take your application down in order to do it. And we can recreate our droplet using the higher memory plan to do that. So here's how we take a live snapshot. Just like every other DO product, very simple. You just click one button, and the snapshot will be ready within some time, depending on how large your disk is. We'll be copying those bytes, and it'll be available within a few minutes. Here we can create the droplet using the snapshot that we built. Great. So now we're relaxing. We got plenty of runway to go build more products and build more features. And we're just enjoying our weekend, really. But then something happens that happens in every basic startup, any company that's just getting started, is that when you think that you can relax, you can't. And we get our first production alert that our disk usage has exceeded our threshold that we set in our alert policy. So what do we do about this? Well, one of the great products at DO is block storage. Great thing about block storage is that you can have up to 16 terabytes of space in seconds. Now, I have a demo set up ready to show you how quick and easy that process is using our DO control command line tool. So the first step we want to do is list all our droplets. So we see the droplet that we have, and the next thing that we want to do is create the volume. And we'll create it with some nominal amount of space, and then attach it to our running instance. Now all this happens in a few seconds, and will be available for your droplet to use pretty quickly. The only additional step you need to do on your droplet is format that disk, which takes a few seconds, and then have your application use that new disk path, that new path in your file system. So with that, we can then add our user content to that space and never have to worry about running out of space again. Additional features like live resize, which means you can expand the storage of your volume instance while it's running, are useful because then you don't have to do this again. So at DO, whenever we get something bad happens, essentially, we have a production issue, we take that time to look back at what we could have done better, what steps we could have taken to avoid the issue. And what we've seen up until this point is that we've been continually adding to a single instance, right? We've been doing what's called scaling up. And the problem with that is that you eventually run out of space. One machine can only hold so much memory, so much disk space, and that it also becomes a single point of failure. So if that one machine goes out, you have nothing backing that up that your users can use to handle their requests. Ideally, you want a system where your users can talk to multiple application servers, and those application servers can talk to multiple caches. So if one fails, it just talks to the next one. Those caches can then talk to multiple storage instances. So then you can partition your data out. If you have tons of data, you can shard your data, essentially. So now when you get more users, it's just simply adding more infrastructure. And there's no single point of failure here, right? So How do we get to this picture? The first problem that we've discovered, though, is when you create so many instances, it's hard to figure out where one instance is when it needs to talk to it. So if our application server is running, how does it know where our currently available caches are? And when our caches are running, how do they know where the block storage services are? That problem is called service discovery, right? And with service discovery, it's something that we use every day without whether you realize it or not. When your web browser needs to talk to google.com, we don't know the IP address that it's at, but we can talk to a service that can tell us. DO understands that this is a problem that if you were to stand up your own service discovery using something like etcd or Console or your own DNS server, it's pretty hard. So we've introduced two products to make that easier for you. The first one is Droplet Tagging. With Droplet Tagging, you can tag your instance as your production cache or your production database. You can tag it as your staging database. So now you can look at your infrastructure and basically understand what instances have what responsibilities. The next part is load balancers. Load balancers play a very intricate role in architectures that have no single point of failure. So now, instead of your application server knowing all the instances available and talk to them, it talks directly to a load balancer, and that load balancer shares that load across all the instances. So in order to use both these products to create our service discovery pattern, we simply just need to create a load balancer and assign to it tags of the droplets that we want to use. So if we wanted to create a load balancer that load balanced across all of our caches or even all of our application servers, we simply add that tag to our load balancer. And that load balancer is intelligent enough to know when we lose an instance or gain an instance. So if you spin up a new instance of your cache, there's nothing to update. It automatically is added to your load balancer. You can configure things like what port you want it to load balance on, if it's an HTTP server, like your application server running on port 80, or if you want it to run on TCP for your caching layer. On top of that, you can also configure your load balancing policy. So you can configure a round robin, or you can configure least number of connections. Totally up to you. So really, after we create our load balancers and deploy them to our architecture, our system looks like this, right? Our users are talking to our load balancers, which can load balance across our application servers. The same thing happens between our applications and caches, and between our caches and storage instances. If you look at this picture, though, this is pretty small, right? This is about what you would need in one region or one location. But let's look at the globe. Whether you realize it or not, your customers are coming from across the world. And those lines you see on the map there are not just something to reference you to where they're coming from, but it actually represents latency. And what is latency? Latency is the time it takes for your physical data to move from your server to your customer's server, or to your customer's browser, rather. And with TCP, there's a round trip involved with that. So that's a lot of time. The time it takes for something to go from San Francisco to New York is much shorter than the time it takes for something to go from San Francisco to Australia. So how do we fix this problem, right? This problem introduced a lot of load on your application servers, whether you really realize it or not, and that propagates all the way back to your caches and your data stores, right? The longer it takes for your data to travel to your customers, that's load on your servers. So we can fix that problem by using one of DigitalOcean's many data centers. We have data centers in San Francisco, Toronto, New York, Germany, India, London, across the globe. Now, all we need to do is pick up our infrastructure and move it to those locations, right? Seems pretty simple. We can use some of the parts we built earlier, like snapshots and backups, and transfer that data to those regions for free. There's no charge for that. But what we really need to do is rebuild that architecture, rebuild that system. And one of my favorites to use is Terraform. Terraform is a tool by HashiCorp, if you're familiar with things like Console and Vault. Same company, the same team is behind Terraform. And one of the reasons that I like it so much is because DO is a first-class provider. So all of the resources that we talked about today are available in Terraform without having to do any crazy API manipulations. So if you've spun up your architecture using Terraform, you simply just point your Terraform config to a new region. It's pretty simple. So here are the products that we covered today. We talked about how easy it is to create a droplet, and when we need to, resize it. We talked about monitoring and that integration with Slack to make your life a little easier and using one tool to do everything. Talked about floating IP addresses and snapshots and how that makes your application deployment simpler. Our high memory plans are great for using your caching, using caches like Redis. And our load balancers tagging can get you your service discovery that you need. So I'd like to finish today's talk with a couple pro tips that I learned while at DO and generally in my career in general. First one is that graphs are better than logs, 100%. Sure, if you're running a small application, one instance, you can pretty easily grep the logs. But when you're running at cloud scale, when you're running at multiple data centers, that's just too hard to do. You can make much more sense of a picture than you can from some log lines, right? You can tell things like your latency in your application server has gone up, maybe your error rate has gone up, all types of stuff. DO has a few one-clicks that are available for you to use to make this process a little easier. We have an elk one-click that would suffice to do this, but I would urge you to, when you start building your application, that these are some of the things you think about first and not last, because forcing your application to do these things is much harder to do when you've already got a production system running. The next thing is don't scale too soon. Now, we went and built this global architecture that can support millions of users, right? But where did we start? We started with just one instance running on one droplet, and we didn't really need to do more than that until we needed to, right? There's nothing wrong with creating or scaling when you need to, right? It's better for you to provide benefits and products to your customers before spending months and months trying to scale something that no one's really using yet. So my advice is to get the users first and then worry about your architecture. Last but not least, trace everything. Now, tracing involves how data flows from one service in your architecture to another and how they are connected to each other. So when your application server talks to your caching layer, that's a service interaction. Now, tracing does a lot of cool things that tells you where your application and your code is spending the majority of its time. It even tells you where your circular dependencies are. And in any software development plan, circular dependencies are just bad. You can introduce a lot of bottlenecks, circular weights, and locking problems. Right? So we use a lot of tools at DO. Some that I can recommend are anything that uses the Open Tracing API. Those are great. And just like I said with logs, try to integrate this earlier rather than later, because setting up the architecture again is not as easy as it may seem. And last but not least, thank you all for being here today. I appreciate your attention, your time, and that's all.